have a few minutes left, so we're gonna do a pep talk. Who knows making? Anyone make something? You make things? Good. Anyone know programming computer? How to program computers? Oh, good. Anyone make electronics? Make electronics, yeah. You who don't know, you can come here and take course and learn to make electronics of it. So it's great. Who have played with the ESP8266? All right, we have a few. I think you also can find them outside. It's a really exciting thing because it defines IoT. And IoT is now so cheap. It's like $2 a chip, and it's a computer. It's similar to a computer, a home computer we had a few years ago. So it's $2. It used to cost $200, right? Now you can use IoT to toast your bread. So I'm not going to talk about toasting bread, but I'm going to talk about the ESP and the LISP. And because it's a Make conference, I made my own slide software. So it may not work perfectly. So we see what happens. My name is Jonas S Karlsson, and I'm Swedish, but I live in Hong Kong 5 weeks at a time, because when I get bored, I go to another place which have a hackerspace and stay in Hawaii. So you might catch me in Shanghai, Beijing, Singapore, wherever. So we're going to talk about LISP, and here's just a tiny introduction to ESP8266. They come in different formats, but here is a dual core ESP8266. I used to have a quad core, but then I sold two and I had to cut them off. Now it's only there were only two left, so it's a dual core, I call it. You can only use one at a time, it has to have its independent power. But it's really a fun device to get started with and to play with. So what's interesting with this, it has about 40 kilobyte of RAM for your program, and it has 512 to 4 megabyte of flash. And some software give you a flash file system, so you can have files on it, you can read it, you can write it. So it's really kind of a really amazing device, I think. And the price point is totally right. So what I like with this one, and what is really inspiring when you get the one called Node in View, it has Lua on it. And Lua is an interactive programming language. Some people may know JavaScript. JavaScript is, you can go in console, you can type 3 plus 4, and it says 7 maybe some of the time. So you can type something, something happens. And this is very close to how we used to use home computers, right? Nowadays, for most people, you have a computer on your desk, but if you want to program it, you don't know how to do it. You have to install a lot of programs. I think Chrome is trying to change it, so it becomes more like an environment for programming. But I also have an environment where I program inside the browser and it's stored in the cloud. That's another thing I'm working for, called Panda language. We don't have time to talk about that, because that takes 3 hours. But Lua is interesting because you connect to this one as a terminal serial port. You can type commands. You can write in functions and programs, and you can call functions. So you can say read pin 1, and it says, oh, it's 0 or it's 1, right? And so you can interact with it, and you can try out your program without recompiling and then flashing it, because that takes like a minute in a runtime time, right? And then you see, oh, it's not working, I need to change my program. So now you can just do it by connecting. But I try to use this one, and it has 20 kilobytes code free. When you load code in memory, it has less memory, maybe 10K free. And you create a function. Each function takes 600 bytes. And that's a lot. So you can't make a lot of abstractions. So Lua works fine if you have 1 page of code. That's it. And that's not much. Okay? So I want to make something more efficient where you can have more abstractions. So I worked on a list. I said, I haven't written a list for a few years, so let's do it again. Yeah? You should always do things again, because the next time you do it, you learn something new. This is very special because LISP, how many people know anything about LISP? 1. Okay, I'm going to teach you Lisp today, so don't worry. Okay? We're going to be full Lisp programmers after 12 minutes. Okay? So, I'll teach you. Alright? Very easy. This is a number. You type the number, you get the number. That's it. And this is a string called hello world. This is possibly the shortest hello world in most languages you can use, right? Just type this, quote, and it will print the same thing back. It's a program. This is a Lisp program. Okay? Symbols are just names of things. But it can also be X, and it can also be plus. Plus for any letter combinations. And it's essentially anything which doesn't have a space in it. It's a symbol. As long as it's hit together. And symbols is what Lisp can do, and almost no other language can do. Okay? This is nil, is nothing. And we just write like parentheses. It looks like a very short list, and it is. It's an empty list. Okay? Then it has a pair. And it's not a pair you can eat, because my pronunciation is funny. It's a pair of two things. Right? And the dot signifies that you have one thing and another thing. And this is the only data structure which most Lisp always have this. And it's the only thing you need actually. Now, if we put 3 in a pair and nothing in the end, it's called a list. So it's not a pair. It's still a pair, but it ends with a name. So this is the definition of a list. And we can combine it, and this looks complicated, but when we print it out and type it in, we type this. It's the same thing. It's just 3 pairs connected. The last element is empty. Okay? So, now we're going to call the function. We're going to add 3 and 4, because we know this gets 7. Often, very often it gets 7. So, actually what we see here is a list, and it has 3 elements. First element is a symbol plus, second element is a number 3 and number 4. So it's a list. This is data, but it's also a program. This is unique for Lisp. Okay? When I call 2 functions, we put this together. And this is where people get afraid because, wow, there's 2 parentheses in a row. I don't understand. Or I hate Lisp. But it's okay. It's okay. You can do that. Now, we're talking about hardware and doing things. So this one, I added 2 functions to my list. One is called in, and one is called out. In takes a pin number you want to read the value of, and you can read it. And out takes a pin number and the value you want to write, 0 or 1. Okay? So that's very simple. And it's very easy to add these functions to my language. It's just 3-4 lines of C code. Now we're going to define a function which doubles a number. The number we give is the double n. And we have an n, so we say plus n. So this is how we define a function in Lisp. And it just doubles a number, right? And if we call it, we say double 7. And we hopefully don't get 7, we get 14. Right? Okay? It's still a list of 2 elements. Right? Now, if looks like this, also parentheses. If equal 3 and 3, because equal is a function. If is a function. So equal 3 and 3 will return true. And if it's true, it returns a green string. If it's not true, it returns a red string. But this could also be another program or data. So you have control. This is how you program. This is the if statement condition. Okay? How do you loop? This looks a little bit more complicated. And in the end, it's all the parentheses you hate, but you can give it to your grandfather because he's that old that he probably knows this. So loop n. We run the loop n times. If n is less than 1, then we do nothing. If we return nil. If it's bigger, which is the else, we construct a pair of n and then loop of n minus 1. So if it's say loop 5, this will call loop again with loop 4, and loop 3, loop 2, and loop 1, and loop 0, then it returns nothing. So if we call this one, what we get? We get 5, 4, 3, Lisp has no loop constructs necessarily. Just call the function again, and if all you need. Very simple. It's like a minimal virtual machine. Okay. This Lisp is interactive, so I try to make it fun to connect to, and I'm going to show you that in a minute. But there's commands like trace on and memory, so you can debug it. You can say like, how much memory do I use when I run the +3 and 4? And we'll show you that, oh, allocate the list and it's up the list. That's a little bit built-in help. And you have some magical keys you can type while something is happening. You're going to see that too. So let's do that. All right. Okay. I'm going to possibly put down this one. Sorry?
Could you increase the font size?
Yeah.
Better.
There's a Lisp, and it usually says Lisp. And then, if it's basic, it says ready. And you can do 3 and 4. Somebody will tell me the result. 10. Alright, let's see. Sorry, 7. Do it again. Alright. So this is a very simple Lisp, right? You can do things. So I can say help. And it says blah blah blah, and then it says symbols. These are all the functions it has. It has about 100 functions in it already, so it's quite useful. Actually, these functions is enough for me to implement a basic interpreter. Somebody used basic when you were a little bit younger. Okay, so I wrote a basic, and I would like to relate to that in Lisp. It's just a few hundred lines of code. It's very simple. So Lisp is very good to do symbolic manipulation and program with symbols. So try to do that in C. Takes more lines. Okay. Now I'm going to run a function which takes long time. Well, somebody know what Fibonacci is? Fibonacci is the computer's nightmare function because it calls itself twice. So Fibonacci of okay, finished. Huh? But when you increase the number by 1, it does at least the double amount of work. So it's exponential complexity, it's called. And it will also use a stack because it grows. So it's really a test of the speed. So you can use this for benchmarking. It's like, oh my god, okay, it's doing something. My computer is doing something. I don't see it. My computer is hanged. What can I do? Oh, I'm waiting 1 hour. So this is a problem when you connect to a device and connect to this thing. You don't know if it's still working. So you put print statements, you program it prints a dot, but you put it in the tightest loop, so it just prints dots and doesn't do anything. So it's like, oh, when you start modifying it, so it prints later. Okay. Well. Is this doing something? Well, you think it's doing something?
I think check the fan.
Check the fan, yeah. Actually, I run a Unix command before, it says disengage fan. But actually, this is running on the ESP. It has no fan. We can help him. Okay, so it's still maybe doing something. How many people think it's actually doing something now? I'm not sure. They hang sometime, okay? I have a magical command. I press Ctrl T now. And it shows the time since I started the ESP. And it shows the load. It's a supercomputer, it has load. Okay, so 93%, 9%, it means it's busy doing something. And it's at 22 people. 22 people means that it has 22 functions of people calling each other, waiting for results of the other one. And this keeps varying because it keeps doing it. Oh, we're finished, and we got a number. Can you verify my number is correct?
Looks good.
Okay, it looks good. It's a big number here. So, it finished. But meanwhile, we could check, we could talk to it, right, and see that something happened. That's good, but it's not perfect. Let's do it again. And we're running and running and running. We say, oh, I give up. Take too long time. We press Control C. What is Control C? Break. Right. Break. Gonna break my computer? No? Okay. Break. And here, it shows me the stack. So it's a function called Fibonacci of 30, which calls a function called Fibonacci of 29, that calls the Fibonacci of 28, which calls 27, calls 25, calls forever, right? And now, because I break it, I could make it go into debug mode, which I haven't implemented yet, and you can continue and you can change the values, maybe, not yet, but it'll take a few days of hacking, right? Tomorrow, you help me, yes? So this is really exciting. The overhead of checking for the Control C and Control T is not even 1%. I do it every time I garbage collect. So if your program generates no garbage, you can't break it. That is this, so it's all garbage. Okay? It's all data, and when you don't want the data anymore, it's garbage. Okay? So this is cool. And observe here, like you type something and you can delete it. Ooh. Some of this command line program cannot do this. I had to write the function to it. I had to interpret the Control H, and delete, backspace. But this is cool, but you have to type in the function every time you change it, so that's less cool. So we're gonna play the other core, my supercomputer. Okay, connect to it. Is anything happening? Not. I press Control L. What does Control L do? Clear the screen. Read all the screen. So, anyone knows what Emacs is? How many people hate Emacs? How many people love Emacs? Nobody. You all use VR, right? I hate you. Okay, so Lisp is cool, Emacs is cool, and VI is okay. But it has one function, and that is it allows you to edit full screen. So you can walk down, you can go forward, you can insert text, and it shows you what you have in the file. This one is running on the ESP. So I was bored, and I had a lot of hackers around me in Hong Kong in the makerbase. So I sat down and I wrote this function in like 3 hours. It's about 300 lines of code. Implement a very simple full screen editor. You can page up, you can page down, and we're gonna add cursor keys at some point. It's like now a cursor key in the VT100 terminal do this way. But the idea is, if I combine this program with a Lisp, we can say, oh, this function is an edit on this function, and we get the screen of a function, because in the Lisp, the function is data. Because it's data, we can print it. Because it's data, you can edit it, and you can save it again. So we can connect to this one, and we can edit it online while connecting. So you don't need to install any software. Most computers come with a terminal program of some kind. So this is easy to play with and interact and call functions, right? Okay. Am I out of time, or how is the time here? Somebody else talking? I can go on forever. How many people will continue forever? All right. 1 minute. Okay. Any questions? Yes.
With the Lua, there is 20 kilobytes remaining.
Sorry, with the interactive Lua interpreter, there was 20 kilobytes remaining, but with this without the editor and this with the editor, what sort of resources does it take off of that?
Right. So the editor is interesting because possibly you need to keep the text in memory. So that's the biggest cost. So the code does not take any place of the RAM at all.
It's in Flash.
It's in Flash. The C code compiler is in Flash. So I can add 1 billion functions, and the only thing which takes space is the symbol names, right? But for the Lisp, I'm working on a function where you define a function and it will automatically store it in Flash. You'll be able to execute it from Flash. Because there's one area of the Flash memory you can write and read from as if it was RAM or ROM. So you have about 20K available, but it's about 16K in the Lisp because I pre-allocate some memory in order to save memory. It sounds funny, but I've gone through many stages of optimizing it. For example, the symbols you see, any name up to 6 characters, just characters, does not take any memory space at all. It's stored inside the pointer. And so I do a lot of funny tricks. The numbers are not allocated on the heap either, they're stored inside the pointer. And so certain bits in the pointer have certain meanings as well. So there's a lot of funny tricks you can find in the code. Okay, time out! Thank you.